We're doing real sinusoids. Real sinusoids have to do with a neat little sound. We're going to do real sinusoids today with making equations from real movement. And the first one we're doing is taking our finger away from our nose and then bringing our finger toward our nose and then away and toward. We did as a class 6.3 seconds to do 10 of them. Our period is going to be 0.63 seconds. Okay? Then the distance when the finger is right at your nose, how far away is that? 0. And then we're going to measure furthest away. We need somebody who has an average length of an arm. Alec, why don't we use you? Stick your finger way out, and I won't jab you with this. Promise. About 0.71. So we'll go distance far, 0.71. That's pretty far, by the way. Who has a shorter one? Let's see. Here. Let's try this one. Okay, 0.52. So the average is about, let's go about 0.58 meters. That's what we'll do. So if we were to graph this, we could start the peak wherever we want. We're going to start far away, and we're going to go like this. Goes down, comes up, comes down, comes up, like that. Okay? And how long did it take to do one complete cycle? 0.63 seconds. And for an average person, it's about 0.58, and this was 0. And what we can do now is we can make this equation. So the equation is going to be y is equal to d plus a cosine b t minus c. We're going to calculate d. D is this part right in the middle. What do you think that's going to be? Well, it's going to be 0.58 plus 0 divided by 2, which is about 0.29, right? 0.29. Right? So if the middle here is 0.29, how far is it from 0.58 to 0.29? How far is the amplitude going to be? 0.58 minus 0.29 is just going to be what? 0.29. That's just because we're bottoming out at 0. Now for the cosine b, b is going to be 2 pi over your period. And the period is 0.63 seconds. I'd just leave it like that. And there you go. 2 pi over 0.63. C is wherever the first peak is. Where's the first peak? Where do we start our finger? Close or far away? Far away. And that's 0 is where it was furthest away. And so t minus 0. I like using 0 every time because I can choose where it is. And there you go. There's a cosine. That's a graph that tells you how far away your finger was going that fast every second. It's pretty cool. You can do that. Question? A is the amplitude from rest position up to here. 0.58 minus 0.29. We're going to try one more on this video. We're going to do sitting and standing. And what you're going to do is you're going to sit down, stand up, and we're going to do up and down. I'm going to kind of control how fast you go up and down, and then we're going to build a sinusoid. So for this one, you're going to use some data. We're going to use a stopwatch again, and then, but we'll also use some data that's given. There's an object that moves up high and then down low. It just keeps going high and low. The low is 5.2 centimeters, and the high is 11.6 centimeters. It moves between those distances from a fixed point. And all we need is the period, and then we could figure out what this is. By the way, what could we figure out with just this information? What could we find? D, which is going to be 11.6 plus 5.2 is 16.8 or 8.4. And then we can find, this is really easy, the amplitude is from the high down to the middle, or 8.4 minus 5.2, which is 3.2. Okay, and we're going to choose 0 to be the high point. So all we need is the B value. So how are we going to get that? Well, we're going to have to measure the time for things to go up and down 10 times. Are you ready? Here's the image that we're going to use. This 10 is all we need. Yep, go. So we had the period for 10 cycles was 4 point what? Did she say? 4.3. So that's just going to be 0.43 seconds. So the cosine 2 pi over 0.43, that'll give us that nice little cosine curve. And I'm going to draw a sketch of it just so you get a visual of it. The close position was 5.2. The far position was 11.6. Okay, and we started at the high, and it just goes like that. And one complete cycle is 0.43 seconds. Half of that would be, 0.215. And that's what the graph of that one looks like. Pretty amazing. One of the most successful of all curves is the sinusoid. It matches reality better than any others that we've come up with. Turn to your neighbor and see if you can come up with 2 real-life applications of things that oscillate. I'll give you one. Daylight hours. June 21st, you have the longest day. When do we have the shortest daylight hours? December 21st, somewhere around there. And then it gets longer days. We're in the longer day cycle now. Then it'll become shorter after the 21st, and then longer and shorter. So that happens in a real predictable manner. See if you can come up with 2 ideas that do the same. Go. How about over here? Anybody come up with one? I'm looking at Justin. Can't come up with one? Something that changes, increases, decreases? No? Okay. Yeah. What's that? The what? What's that?
I'm going to say it.
Okay. Any other ones you have? Yeah? Yeah, and as the Earth goes around the sun, it gets closer at certain times of the year and further away. And the reason why we have our seasons isn't just closeness. We can be closer, but it has to do with the tilt too. But there are the times that we're furthest away and tilted away have the coldest time periods of the Earth. So yeah, close distance to the sun would be a great one, perfect example. Any other ones? Ooh. A fan, a distance of a point on a fan to like a bug that's sitting on the edge. That's perfect. Excellent. And think of yourself in a carousel and somebody's riding it and they move away from you and then they come closer to you, away and then close. That's a great example. Somebody mentioned like the horses. If you're riding on a carousel, they're going up and down the distance to the ground. Lots and lots. Most rides that are cyclic are going to be sinusoidal. Yep. Any other ones? Okay, good.